Welcome everybody. This is an interesting question. We are expected to let capital R be the radius of the quarter circle OAB, or I would say, okay, never mind, OAB, and let small r be the radius of the quarter circle OPQ. So this radii is R, this entire length is capital R. Now if this is R, definitely this should be R, and I can connect P with O, right? So this is a right triangle. We see that PQO is a right-angled triangle, right? So by Pythagoras theorem, what do we have? We have OP squared is equal to PQ squared plus OQ squared. I do not know OP squared. Now this entire length which we see here is capital R, right? So that is a very important component that we would have to use. So that means this entire length is capital, right? We have to get this distance. So let us see how we are getting it. So I can write this as capital R. So by the Pythagoras formula which we have here, OP squared, so I got R squared is equal to PQ squared, R squared, OQ squared is again R squared. So this is 2 times R squared is equal to capital R squared. So capital R is equal to 2 times R squared, which is nothing but root of 2 times R. So this is the radii expressed. That means the circle OAB as a representation in terms of OPQ. So capital R is equal to R times the root of 2, right? Now an important fact you have to notice here is that this is an isosceles triangle. That means this will actually form a part of another triangle, so that these two would be a square, right? So that is the geometrical property. So fair enough, we have now got a beautiful figure. The question now here is, foremost, we will have to extract this segment. Okay, we need to extract that segment. So let's see how to do that. So let me color this as a green segment. Okay, so area of the green segment, area of green segment is equal to, now this entire region is a sector, okay? Say PQO is a sector. So from the area of the sector PQO, what do? I subtract the area of the triangle PQO, right? So what is the sector area? Area of sector is theta over 360 pi times the radius squared. So what is theta here for this region? What is the theta? What is the angle that is actually being subtended by this arc? This arc is subtending an angle of 90 degree. So 90 over 360. And what is the radius here? R. So it's going to be r squared. So this is going to be pi r squared. 9 divides here 4 times. So you have 4 there. Square units. So this is the sector area. Now what is the area of the triangle? Area of triangle PQO is half times base into height. This is a right triangle, right? So half times my base is r, my height is r. Base is r, height is r. So you have r squared over 2. So therefore area of green segment is equal to sector area minus triangle area. I can take r squared over 2 out, and that would give me pi over 2 minus 1, right? So if you have to rewrite this, you have r squared over 2 pi minus 2 divided by 2. This is what you got. You can further rewrite it as r squared times pi negative 2 divided by 4 square units. So this is the area of green segment. So okay, now we have got the green segment. Go back to the figure. Now if you see here, we have another sector that is being seen here, right? There is another sector that you can see here. In this sector there is this region which has got area of 4. Now what I wish to do is, I would want to make a representation for this area. So to get this area is going to be equal to, from the sector I have to take away the green area. Okay, so let us actually get that. Given area, given segment area, to get the given segment area from the area of sector. So what is the sector? OAP. OAP, we take away this green region, right? We take away the green region, green segment, minus the area of green segment. This area is given as 4. The area of sector OAP. So let me calculate this. Area of sector OAP. Area of sector OAP is now, as I mentioned to you, this is 90. This angle is going to be 45. So this angle will also be 45 because it's part of a square, right? So this angle is 45. So this is going to be theta over 360 pi times my radius. So what is the radius? You're talking about the radius of the quarter circle, that is capital R, right? So this is going to be capital R squared. This is 45 over 360 pi capital R squared. Now 5 divides here 9 times. 5 divides here 7 and 2, 72 times, and 9 divides here 8 times. So you have pi capital R squared divided by 8. So hence, if I were to take this as say sum 2, okay, I can rewrite 2. Hence 2 is rewritten as 4 is equal to this region. This area is pi capital R squared over 8 negative green segment region. Okay, we have to use this green segment region. Okay, so let me write this down. This is going to be R squared of pi negative 2 divided by 4 units. You got 4 units here. And R, capital R is R times root 2. So divided by 4, capital R is R times root 2. Right, is it not? So this is 4 is equal to pi R times the root of 2 squared divided by 8 negative R squared of pi negative 2 divided by 4. So this is going to give me pi times R squared times 2 divided by 8 negative R squared of pi negative 2 divided by 4. This divides here 4 times, so pi times R squared over 4 negative R squared of pi negative 2 over 4. Now I can take R squared out, 4 out, and this will give me pi negative of pi negative 2, right? Because R squared over pi, R squared over 4 into pi gives me the first term. R squared over 4 into the second term will give me this term here. So fair enough. So this is going to be R squared over 4 pi negative pi. Pi negative pi positive 2. They get cancelled, giving me 2 times R squared over 4, which means R squared over 2. But on the left side you have 4. 4 is equal to R squared over 2. Therefore 4 times 2 is equal to R squared. So R squared is equal to 8. So R is equal to root of 8. Can I write 8 as 4 times 2, which means R is equal to 2 times the root of 2, right? So this is the value for R. But what is actually R? R is the radii of the quarter circle. So therefore area of the quarter circle PQO, I will just write it as area of the required quarter circle. Required quarter circle is equal to pi times R squared divided by 4, which is nothing but pi times over 4 times the value of R. The value of R you have got is, we just got the value of R, okay, 2 times root 2. Right, so 2 times root 2 squared, which means you get pi over 4 times of 2, right? 4 gets cancelled, giving me 2 times pi square units. Okay, so this required area is 2 times pi square units. That's exactly what we have got, 2 times pi square units. This is the answer to this question. So please like, share and subscribe. Thank you everybody.